Welcome to Astronomy, Chapter 7. Now, this chapter is the third in our second unit, and it is going to be talking to you about the other terrestrial planets. Now, when we say the word terrestrial, what we are meaning by that is we're saying a terrestrial planet is a small, dense, hard outer shell, rocky planet that's very close to the sun and very close together. These planets have a lot of things in common, and they're a style of planet, if you will, and we call them the terrestrials. And they have all those traits in common. And we looked last time at the Earth and the Moon, and in this chapter, we're going to take a look at the remainders, that being Mercury, Venus, and Mars, and try to see what are some of their traits, and what are their similarities and differences relative to the Earth and to amongst the other terrestrial planets. And so we start off by taking a look at Mercury, and again we see these vital statistics. The first thing, though, we notice about Mercury when you look at it is you go, wow, that kind of looks like the Moon. That is the thing that the most immediate reaction most people have. In fact, they give you a comparison down here, Mercury to the Moon, and not only do they look alike, they're actually awfully close in size. Mercury is very small. It is much smaller than the Earth. The Earth is about 4 times the size of the Moon, roughly. And so Mercury is not much bigger than is the Moon. So they're on that order. And the example I usually give is if the Earth was a basketball, the Moon would be roughly a baseball, and so Mercury would be like a softball. Those are good, rough at the ballpark estimates of their size. But Mercury, as it turns out, does have a tremendous amount in common with the Moon, having a surface that is heavily cratered like the Moon, and having these impacts all over its surface are interesting. But what's neat about Mercury is an area that has been studied in good detail only very recently, which is odd when you think about it, because we see this image right here coming from Messenger, which is a late, a 21st century mission to study Mercury. Now, it may seem strange to think, why did we wait until now to study Mercury, and why do we know so little about it? Well, if you think about where Mercury is, that's the closest planet to the sun. And if you go outside on any given night to look for Mercury, you never see Mercury very far above the horizon. Mercury, having a small orbit close to the sun, means that it's very difficult for us to see it. So we get very little telescope time with Mercury. So in order for us to study this object, we had to send a spacecraft to it. The first one was Mariner 10 back in the 70s. And actually, we didn't do anything until Messenger in about 2012 and 2013. We started getting some information out of that mission. And that has returned a wealth of information. And the beginnings of that are posted in this book that we're looking at. And so these impact craters all over the surface have provided a whole lot of new insight to how Mercury is put together, and how it works on the interior, because up until then we had almost no idea. Now, Mercury has a very unique trait that we need to address here in the second section here. It says Mercury has a higher percentage of iron than does the Earth. What that translates into is Mercury is very dense. Very dense. It's, in fact, the most dense of the planets. It has a very large core. A substantially higher percentage of the planet is the core. And it's about 75% of the diameter. It makes up the core material, whereas on the Earth it's only about a little over half is core material. And that's in diameter. So it has a large percentage of iron inside of it, making it very heavy and very dense. And so that causes the question, well, why is it why does it work that way? There's still a lot of research that's being done about Mercury. And only recently have we learned about the magnetic field of Mercury. In fact, that was one of the things that Messenger set out to do, was to answer the question, what is the magnetic field like around this thing? And it turns out it does have a magnetic field, albeit a very weak one. Another odd trait of Mercury is its rotation. Its rotation and revolution are coupled, and what that means is it actually works similar to the way the Moon orbits the Earth. That is, it appears to be facing towards the sun, and they kind of give you a really great diagram on the top of page 204 to talk about this spin coupling idea. Make sure you read through there to see this idea, and I believe you can go online and find some animations that show you this in motion, although it is drawn out for you there relatively nicely. But Mercury has a couple very unique traits, and virtually all of them are driven by the fact that it is so close to the sun. Mercury is by far the closest planet to the sun, and therefore it has a lot of traits, one of which is the temperature, and that the temperature on the side towards the sun is very, very hot. But then the temperature on the backside is very, very cold. And that's due to the fact that Mercury has a very weak atmosphere. Its atmosphere is so thin it doesn't trap hardly any heat. In fact, Mercury is basically considered, like the moon, to be almost airless. There's essentially no air there. But it has a very, very thin atmosphere. And so it does almost nothing to trap and to move around that heat like our atmosphere does. So Venus is a unique world that is very similar in a lot of ways to the moon. Now, taking the next step out is to Venus, which is, of course, the second planet from the sun. Venus is, interestingly, much more like the Earth. Venus is very similar to the Earth in many, many ways. And not the least of which is the fact that the Earth and Venus are the two closest objects to one another, the two closest planets of any two planets in the solar system. We're quite close to it. So what that means is Venus being about 95% the size of the Earth, meaning it's a big terrestrial world. So on my scale, if I said if the Earth is a basketball, then Venus would be like a volleyball, almost the same size. And they're very close to each other. So what that means is Venus is very bright in our night sky. In fact, if you've ever gone outside and shortly after sunset or shortly after sunrise and seen a incredibly bright object, what looks like, many people mistake it's got to be a UFO or some weird object out there. And almost always that is Venus. In fact, as an astronomer, I get asked this all the time and hear people say, I saw this strange object in the sky last night right after sunset. It was in the southwest. It was really bright, but I didn't know what it was. Well, the vast majority of the time it's Venus, because Venus is actually the third brightest thing in our sky after the sun and the moon. Venus gets to be the next brightest thing. It is very bright. Now, for being such a bright object, we, for a long time, really struggled to see the surface of Venus. And on the vital statistics page, they show you this nicely. That Venus has an atmosphere that's completely clouded over. And so even though it has many traits similar to our planet, it's about the same density, it's about the same gravity, it's relatively close to us in terms of distance from the sun. One of the big differences is the atmosphere of Venus. And the atmosphere of Venus is impressive. It is very, very thick. And in fact, it kind of looks like a mocha latte or something here. This mix of brownish clouds makes for an incredibly thick atmosphere around Venus. It has this extremely strong greenhouse effect, and they talk about this on page 208, that this greenhouse effect causes an incredibly high surface temperature, approaching 900 degrees Fahrenheit, 800 and some odd degrees Fahrenheit at the surface. That's hot enough to melt a variety of metals at the surface. Of course, the Earth's surface temperature is somewhere, on average, about 60 degrees. So it's very, very hot on Venus because it is trapping virtually all of that heat. How does it trap that heat, you might ask? Well, it's trapping that heat through the greenhouse effect. Now, we know the greenhouse effect on the Earth helps keep the Earth warm and is caused by carbon dioxide. Well, guess what? Venus does the exact same thing. It just does it much better than the Earth does. If you think of better as in it traps more, Venus traps that heat very, very well. So then the question becomes, once we knew this, well, where did that carbon dioxide come from? Well, if you do a little searching, you'll find out that we believe virtually all of that comes from the fact that Mars appears to be covered in volcanoes. A very active volcanic world. So there is lava spewing all over the surface, and volcanic eruptions are very rich in carbon dioxide. And so we think that these active volcanoes are what is driving many of the processes on Venus. Now, we did not know this until radar was invented, so that we could actually peer down through those clouds by sending radar beams down and hitting the surface to be able to figure out what was down there. And in doing so, we finally got a good sense of what was going on with the surface. And in fact, we have sent a couple of objects down to the surface of Venus. However, the problem is, with that atmosphere being so thick, not only is it very hot, but it has an incredibly high air pressure. Air pressure so strong that any spacecraft that we sent down is crushed like an aluminum can being crushed by your hands. It's very, very strong. In fact, there's some information that I read once that said Venus's atmosphere is so thick, if you could stand the heat and stand the acid falling from the sky and all the other things that are going on, you could strap some wings onto your arms and fly through the atmosphere because it's so thick and dense near the surface. It's a very cool thought to think about what's going on with Venus. All right, the last one we need to look at quickly here is Mars, and I'll just touch on this briefly because honestly, we could probably do an entire semester talking about Mars, what we know about Mars, all the information we have about how exciting Mars is, and it's being the only other planet that has the potential for life on it. Perhaps some of the other objects we'll look at later may also have life, but the only other planet in our solar system that has the potential for a human being to ever put a boot on the dirt is Mars. It's the only one. And it does so because of its reasonable temperature. It does so because it's not particularly inhospitable. It has a rotation similar to the Earth, although it is significantly smaller than the Earth. Not only, so Mars is about half again as far away from the Sun, so it's colder. It's also about half the size, roughly. And so this area has been, once we knew the temperature of Mars, and we knew that it was very similar to the Earth in a lot of ways. It has an ice cap, although it's very different. It has a tilt and creates seasons and all these things. For centuries, we have been obsessed, absolutely obsessed with finding life on Mars. And nothing was more obvious. That the height of this was when we talked about the Martian canals. And there was this illusion created by Schiaparelli, and then later on the idea of a canal being mistranslated into from a canal from the word channel, and of course the implication was that if there are a canal, that means that there must have been a human civilization there to create that channel, that ditch, right? So that led to all sorts of wild speculation about aliens and life on Mars. And in fact, it was in 1907, the Wall Street Journal said that their post was that the most amazing part of science for that year was the proof through astronomical observations that conscious, intelligent life lives on planet Mars. We were convinced a little more than 100 years ago that there were aliens on Mars. And so the question became very quickly, when will they invade? And, we have a lot of resources. Would they come and take them? And so that idea, of course, was all drastically blown out of proportion. And later on, after we sent more crafts and got better views, we realized there are no man-made canals on Mars. They're not there. It was an imagination. It was, an illusion. We now know that Mars is effectively a cold, dead rock. There is no life there, at least none that we have ever found, as of the moment this video was being made. But what we do find is we find lots of evidence for the potential for life. Because we see a lot of the same features. We see an area that must have been geologically active, like the Valles Marineris. And we see topography that is has a change in topography from the highlands to the lowlands. We see volcanoes. We see all sorts of features that are like the Earth and hospitable. And the thing, though, that I think is by far the most interesting We could talk about its atmosphere, we could talk about all those things, but really the thing that really drives the study of Mars is one thing, and that is water. There is enormous evidence that suggests that surface water was once all over Mars. And in fact, there is now significant growing evidence that there is perhaps water just under the surface, groundwater. There is a lot of evidence to support that. We see tremendous drainage, what look like drainage ditches, dried riverbeds. Perhaps even there were small oceans once on Mars. And if that were true, what we know about life on Earth is water is necessary for life. And so that begs the question, when we see things that look like water ran out of the side of the hill, does that mean that there was ever life on this planet? So that is a fantastically exciting thing to look at. And I really encourage you to read this carefully throughout the rest of Chapter 7 about how we've been searching for microscopic life. And really there is tremendous other information that goes into studying the potential biology of Mars. But it is a topic we could talk about pretty much all semester. But the last thing that we need to look at in here is that Mars has one other feature that is unique, and that is Mars actually has moons. In fact, it has 2 moons. However, the moons of Mars are very different than the moon of Earth. The Earth's moon is large percentage-wise compared to the Earth, and it is round, very spherical. The moons of Mars look more like potatoes, is the description here. And in fact, almost certainly, these moons, which are irregularly shaped, cratered, and very small, almost certainly these were once asteroids. And they were asteroids that got picked up by Mars's orbit, and by the fact that the Mars orbit takes it into the edge of the asteroid belt. Almost certainly, once upon a time, Phobos and Deimos here, the moons of Mars, were large asteroids that were captured. But Mars is certainly a fantastic world to study, being the last of the terrestrial planets we're going to look at. And the last thing I want to leave you with is on 228. They give you a great sort of flowchart and little comparison here to give you the idea on the basic statistics of the difference between these objects. Talking about temperatures, sizes, the description of the surface, their atmosphere, the magnetic field, and their interior, giving you a quick overview of how all of these are similar and how they are different. It's a unique view of what's going on with these 4 terrestrial planets. So, once you've gone through the reading for this chapter, you go ahead and make sure you take a look at the PowerPoint that will guide you through this. You should be ready to get going on the Chapter 7 homework, and good luck.